Hello, this is part 2 of the video on law of cosines. In the first video, we looked at practical problems involving law of cosines where we introduced the first formula here. That's the main formula. It says a squared equals b squared plus c squared minus 2bc cosine of a. And this was mainly used or always used for this type of problem where the one I highlighted here. So where we have an angle sandwiched between two sides. That's where we use that to solve for a third side based on the angle that we're given. All right, and then the second equation is over here, and we used this problem for problems like this triangle here where we have three sides and we need to solve for the angles. And a strategy we used was once we solved for one of the angles, we applied law of sines and we solved the other two angles, such as we did in this problem, example 2. First, we solved for angle A using law of cosines. So we got angle A, and then we used law of sines to solve for B. That would be right here. And then we solve for C using the fact that the sum of the angles of a triangle equals 180 degrees. Okay, so here now we're gonna okay, there we go. All right, so now we're at a part where we use law of cosines to solve applications in law of cosines. So it's very similar to where we had applications of law of sines, where we were dealing with angles of elevation or depression, and we had to first solve some angles, and then it was say a triangle sandwiched in another one, and we were interested in say where the height of the balloon was relative to mileposts that were angularly placed with a balloon. So that's where we use law of sines, and now we're going to look at law of cosines in this problem. Let's make this a little bigger so we can see it better. All right, so we have this problem. This example 3 is emergency medicine. So it says a medical rescue helicopter has flown from its home base at point C to pick up an accident victim at point A, 50 miles away, and then from there to the hospital at point B, 45 miles away from point A. Point A, where the accident victim is, forms a 130-degree angle with points B and C. How far is the hospital from the helicopter's base? So that's the word problem that we need to solve. So what I'm going to do is I'm going to make a sketch of this problem to see what we're looking at. So let's go ahead and do that. So it looks like we have a point C over here. That's point C. And then maybe I might need more space. Let me just come down a little more. Okay, so let's put point C down here, and then let's call this C. That's where the medical helicopter is. So that's where it's located. So and then this point says 50 miles away from point A. So we can go to point A over here. This is point A. So this distance is now 50 miles. And then from there, this is point A. Like that. And then from here, we go to point B, 45 miles away. Yes, point B is 45 miles away from point A. So point B is here. So that's point B. And then we join these. See if we can do this in one go. Okay, that's close enough. So, and then this angle A is 130 degrees because that's the conjunction between points B and C. So point A forms a 130 degrees with angle with points B and C. Okay, so that's point B here, like this. CAB, that's our triangle, if you want to look at it that way. And of course, this side is 45. So the segment AB is 45, and let's make this also blue. This is 130 degrees. So that's the triangle we have. So that's all we need to do for our sketch. So let's now come up here and choose which one of these do we need, which one of these two equations. We have an angle sandwiched between two sides. So if we look at let's look at this this one here, this equation. This solves for an angle, and this is not what we want because we're interested in how far is the hospital from the helicopter's base. So the point C is where the helicopter's base is, and then point B is where the hospital is. So we are interested in solving for C. So this is actually A, sorry. Lowercase a like that. So the equation then that we need is the first one. A squared equals b squared plus c squared minus 2bc cosine of a. That's what we're going to use to solve this problem. So let's apply it. So we have a squared equals, well, b squared is, in this case, 50, because this is side B, this is side B, and this is side C. We said that the sides are always opposite of the angles that they're associated with. So we have 50 squared plus 45 squared. Let's make it better 2 here. Okay, and then this is minus 2 times 50 times 45 cosine of the angle we have is 130 degrees. Cosine of 130 degrees. All right. So all we need to do now is plug this into our calculator and see what we get. So I'm going to grab my calculator. All right. So let's type that in. So we have 50 squared plus 45 squared minus 2 times 50 times 45 times cosine of 130 degrees, like this. Like this. Okay. And hit enter. We get that a squared is 7417. So a squared is 74. Well, let's do an approximation. This is approximately. Oops. So a squared is 74. I believe it was 17. And let's see if we can get a decimal approximation. 0.54. 7417.54. So a equals, go back to the calculator, take the square root of this number. So a is approximately 86.125. I need to again keep putting equality signs, but this is approximately 86.125. And let's see what the units are. So 86, this is miles. So then we can come down here. Therefore, the helicopter, let's make a conclusion. The hospital is, okay, yeah. The hospital is 45 or 86.125 miles away from the helicopter's base. The hospital is 86 point, I'm going to put round again to 86.13 miles away from the helicopter's base. So when we have a word problem, we always want to have a conclusion like this. So we want to state what we just found out in words. We do all the math and then make a conclusion back to English in what you just did. All right, so that's how we solve that problem.